Okay, so the next shape we're going to talk about is the cone. Again, we've already talked about cones before. Like we dealt with those when we were talking about surface area. In fact, the surface area formula is still back there on the board from that last test. But now we're going to switch into volume. Now, if you look back at that formula on my whiteboard over there, where it says cone, it was pi r squared plus pi times radius times s. What did that s stand for? Slant height. Now, when we're dealing with cones and volume, just like with pyramids yesterday, we will not be using the slant height. We'll be using the vertical height, or like the true height of the shape. So you can even see on my picture of my cone over there, I have the height drawn on the inside. That's the height that we're going to want. Sometimes it'll be drawn outside of the cone, or they might move the cone a little bit so it's like leaning, or it's got maybe a straight side built into it. But that's what we're going to need to make sure that we're using for our true height. It's got to be coming from that point at the very top of the cone straight down to the base. We don't want to use the slanted sides of our cone anymore for volume. Now, the definition, if you remember, of a cone is that this is a 3D solid with one circular base and a face that meets at a point. Like a pyramid, the cone has that point at the very top. Yesterday when we saw the pyramid, all of those triangular faces that they were kind of angled in towards each other met at that top point. Cone does the same thing, except its face is a little bit different than the pyramid. A cone's face, like the surface that goes around it, is a little bit more smooth. It is still curving, though, because of that circular base. Yesterday with the pyramid, all those faces were triangles, so they're much more polygon shapes, but they still met at that top point. Yesterday we also talked about how a pyramid is similar to a prism. What shape is a cone kind of similar to? A cylinder. Okay, a cone and a cylinder, like these two shapes up here, are similar to each other because they both have those circular bases to them. The main difference, though, is that this has two bases and this one only has one. So when we talked about the pyramid yesterday, on our bell ringer here, we talked about how three of those pyramids, when we filled up that pyramid with water and we poured it into our prism, that the pyramid could go into it 3 times, and that's how we got this formula. We need to figure out what happens with a cone. Do you guys think a cone is going to work the same way as the pyramid did yesterday, or do you think it might be different today? You think the same? Does everyone think the same? Does anybody think it might be different? Like, do you think we could fit 3 of these in here? Do you think we could only do like 2 or maybe more? First period said we could do like 4 maybe. What do you guys think? Same as yesterday? Anyone think more or less? Thank you for being brave, Jackson. Okay. All right, so let's see if who's right. Let's see if it is the same as pyramids yesterday. Let's see if it's more, okay? Now, yesterday, Miles and Myson did a great job, but I want 2 new volunteers to do it for me today. Hayden, come on up. And who wants to help Hayden? You're just pouring water. I'm just going to have you do it on this table, too, I think. Don't be shy. Someone's got to come help him. Thanks, Brady. Don't leave Hayden hanging over here. All right, so you guys are going to do what they did yesterday. One of you should maybe hold the cone, fill it, and then you're going to dump it in here, and we'll kind of hold it up as you guys go. Okay, let's just show the class. This is 1. So do we still think 3?
3.5.
3.5? Okay, let's do another one. Try to get it as close as you can, Brady. That's done. There's 2.
D is 3.
We still think maybe 3? It might work out the same as yesterday. I don't know if we'll have enough room to do more than 3, but let's find out. That's pretty perfect. Good job. So if you can't see, I'm not going to lift it because the water will spill all over the place here. But it is way up to the top. Right? Yeah. I'm not lying, am I, guys? No. Okay. Thank you. Good job. Thank you for helping. All right. So just like yesterday, our cone does the same thing that the pyramid did. It went in 3 times. So now let's think about how that relates to that cylinder. Yeah, when we talked about the prism, I'm just going to cover this up here on my board. A prism was just base times height. Does anyone remember what the formula was for a cylinder? For volume, not surface area, so don't look at that. What was it for volume for a cylinder a couple days ago? Anyone remember? You can look back in your notes too. It's written down. Pi r squared. It was still base times height, right? But we said because our circles are our bases, we know how to find the area of a circle. We wrote it as pi r squared. So pi r squared height was a cylinder. What should I do to that, though, to reflect the cone? Still divide by 3 today. So like yesterday, our cone behaves a little bit like the pyramid does, but we're relating. A pyramid and a prism have that relationship together. A cone and a cylinder have that relationship. It would not necessarily work the same way if we did a pyramid to a cone, or I mean a cylinder, okay? Because those base shapes are changing, so it wouldn't quite translate the same way. All right, so all we need to do these problems today is our radius and our height. If we have those 2 things, it's pretty cut and dry. You just plug it in and you just keep chugging along and you type it into your calculator, okay? If we don't have the radius, if we don't have the height, then we're going to have to maybe find those things. You might still see Pythagorean's theorem show up today. We might still be using those 30, 60, 90 triangles to help us find something that's missing. Let's take a look at number 1. Can you guys tell me from number 1 what the radius is? Good, 6. You got to cut that 12 in half. What's the height? It is the 4. Now, I mentioned this earlier, but sometimes the height may be drawn off of the cylinder or the cone. So in this case, this same 4 could be this segment right here. Let's go like going down to that pointed tip. Okay, so it's still going to be 4. Now we're just going to plug this into volume. So pi times 6 squared times 4 all over 3. What's my volume? 48. And what's attached to it? Pi and my label. Good. Cubed. So for a cone, just like a cylinder, you're going to have pi in your answer. So don't forget to put pi. A couple of times on the last unit, even like on that test, a couple of us would forget to put pi on it. So just make sure that you're doing that. Okay. And then your label still needs to be in there too. All right. Let's take a look at number 2. Do we have our radius on number 2? Yeah. What is it? 5. Do we have the height? No. But you know it's 12 because why, Anna? Yeah, it's that Pythagorean triple again. Okay, I told you it was going to show up a lot. So there's that 5, 12, 13. Again, you could use a squared plus b squared equals c squared to solve for that if it's not maybe that triple or you don't remember. But that's my height, 12. So now let's just plug it into our formula. Pi times 5 squared times 12 all over 3. 100. And then pi centimeters cubed. Very good. Okay, any questions on those first 2? All right, let's take a look at number 3 then. What's going on here? There's 2 cones. What do we think's happening with that inner cone? It's hollowed out, okay? If you guys go to the ice cream parlor, if you go to Dairy Queen or Bob's or anywhere that sells ice cream and you're going to get a cone, you don't want it to be a solid cone, right? Because where's your ice cream going to go? So think about like this, or if you've ever gotten like the snow cones and it comes in that cone-like container, there's got to be a hollow center to put the stuff into. So that's kind of what's going on here. We want to find the volume of the two separate cones, the really big one and then that smaller one on the inside. Let's start by finding the volume of the big cone. So I need my radius of the big overall cone. What is that radius going to be? Good, 6. You go all the way across. So that 5 is just from the center to the inner edge of the cone, and then it goes on 1 more centimeter. So the radius for that big cone would be 6, so 6 squared. What's the height of the big cone? Good, 16. And we're going to divide by 3. What do we get for this volume? Good, pi. That's the big cone. Now let's do volume of the small cone, the one that's on the inside. What's the radius of the small cone? 5 squared. What's my height of the small cone? 9. And then we're going to divide all of that by 3, and what do we get? Good, 75 pi. Okay, so then what should I do with those two numbers since it's hollowed? Subtract. So 192 pi minus the 75 pi would leave me with how much? Good, 117. Very good, pi centimeters cubed. There's your final answer. Any questions on our cone shape? Okay, very good.